My name is Pathak and I am a software engineer at Razorpay. As a member of the platform team, my focus is on building and maintaining highly available and scalable systems that powers our payment platform. In today's talk, I will be discussing the topic of peak performance at the edge, that is running Razorpay's highly scalable API gateway. As we all know, API gateways play a crucial role in modern software architectures, serving as a central point of entry for incoming traffic from various sources. However, building and maintaining a highly available API gateway at scale is no small feat and requires a deep understanding of the underlying technology and architecture. Without delay, let's delve into the subject and explore how we engineered our systems to ensure both quality of service and performance are maintained. I have been working on Edge, that is the API gateway that empowers billions of payments every day. This is my first time as a speaker at P99 conference, and I do look forward to learn and connect with everyone. Previously, I have presented at Platform Con. I have been an open source contributor. When I'm not working, I like to work out as well as travel outdoors. Let's talk about Razorpay. Razorpay is a leading fintech company in India, offering digital payment solutions to businesses of all sizes. Our mission is to make payments simpler and more accessible for everyone. We offer a wide range of payment solutions, including full stack payments and banking solution. We also provide neo-banking services, which provides business with a range of financial management tools to manage their finances effectively. We have Razorpay Capital, that is the lending platform that offers working capital loans and other credit products to businesses using their transaction data for underwriting. Razorpay focuses on variety of merchants, ensuring seamless integration. Our payment solutions are easy to integrate into any website or application with support for multiple programming languages as well as platforms. We provide detailed documentations, software development kits, and plugins to help developers to get started quickly. To begin, let's provide a brief overview of how Razorpay manages requests, encompassing the request lifecycle and its associated components. In terms of using Razorpay, there are two main identities which are associated with. First is a merchant. A merchant is a business or individual who uses Razorpay to receive payments. Then there is customer. Customer are the ones who initiates transactions by making payments through the Razorpay's payment gateway. All of the requests which are made by this actor using the suite of products are being served by the API gateway at Razorpay, that is Edge, which provides common functionality used across requests such as authentication as well as authorization. Edge is in a privileged position to generate rich insights which can be leveraged further to identify request patterns and malicious traffic. Post processing, Edge forwards a request to the downstream services. To understand more on the infrastructure, let's see how a request gets processed at Razorpay. Razorpay leverages blue-green deployment strategy, where we use AWS Route 53 to distribute the traffic to these clusters. Both of the clusters are mirror of each other. Now, when the request hits either the blue or green deployment, it is routed through an AWS load balancer, which helps to distribute incoming traffic across multiple instances. This also improves availability and helps to prevent overload on any one instance. After the load balancer, the request is then sent to Edge, which is our API gateway. For today's presentation, we'll be talking more about the usage of Edge in ensuring availability and performance, and emphasize more on how it helps in securing the infrastructure of Razorpay. Let's talk about the tech stack at Edge. Edge uses several technologies to provide its functionality. Let's dive into each of them. Razorpay is completely on Kubernetes, where we leverage AWS managed EKS service. Every single container is Dockerized. For the data store, we use Aurora. We also use a mix of AWS Elasticache Redis. Our custom logics are built using Lua as well as Golang. In summary, Edge uses a powerful combination of AWS services, database, scripting languages, web platform, and containerization technologies to provide a high scalable and performant API gateway. Let's talk about the capabilities of Edge. Edge supports a variety of authentication mechanisms along with RBAC capabilities and fine-grained authorization policies. Edge also provides powerful monitoring capabilities. Our stakeholders can set up alerts and notification based on various metrics such as API usage, error rates, latency, and much more. Security is a top priority for Edge. The platform provides a range of security features such as IP whitelisting, analyzing malicious requests, etc. Another important capability of Edge is capturing insights, which contains detailed information about every request. For example, request pattern or identifying the IP reputation score user agents, or what are the security measures which are being applied for every request, etc., are being derived at Edge itself. Edge also provides DDoS protection to its customers. By leveraging rate limiting, Edge is able to detect, prevent, as well as mitigate DDoS attacks before they impact the API availability. Recently, we introduced a new functionality at Edge, that is load shadow, which helps in actively mitigating incidents and speedy recovery by leveraging the best possibilities of our infra usage. Let's talk about some numbers which are being handled at Edge every day. Edge serves around 864 million average requests on a daily basis. During burst scenarios, this number may reach up to 3 times. Edge handles 5 plus billion peak traffic requests during a day. Working at this scale, it is important for Edge to ensure protection against distributed denial of service attacks. Bad actors conduct DDoS attacks using advanced mechanisms. Razorpay enables merchants and individual customers to leverage our APIs for accepting or making payments. Given the complex nature of payments, it is a challenge to protect against DDoS attacks using an out-of-box solution because we had to distinguish between small merchants as well as large enterprises. So we had to build something custom to our needs. One of the measures to prevent DDoS was to make rate limiter intelligent enough to support this traffic and proactively ensuring a safeguard against attacks. Let's look at the journey of rate limiter evaluation and the considerations which we have gone through. We'll also talk about that at this scale, it is important for us that our infrastructure as well as the compute usage are supporting these numbers. Scenarios where spikes in CPU or memory usage during high traffic or DDoS attacks can have a large impact on overall performance. We'll talk about how Edge ensures actionables during such scenarios. I'd like to present the architecture which not only detects and prevents but also mitigates such scenarios. As I said earlier, Edge provides rich insights being in the privileged position to track all the requests which are flowing through Razorpay. Edge also leverages AWS tools such as Shield as well as the web application firewall on top of it to further utilize the insights in building a robust system to mitigate attacks. AWS Shield provides a DDoS mitigation framework with three key features. First, it provides alarms that can be tailored to trigger when DDoS attack suspicions arise. Second, Shield offers real-time visibility by presenting the top 5 critical field values, which includes client IP, countries, and user agent. Lastly, Shield also provides Shield response team, which helps in our on-call support, aiding in comprehending attack vectors and crafting AWS workflows based on these insights. The other tool that we use along with Shield is WAF, that is Web Application Firewall. It introduces two rule types: blocking rules that enables the blocking of requests matching predefined variables from individual attributes like IP address to combination of factors such as IP plus URL or request body or country or any combination of this. Rate limiting rules monitor requests per originating IP addresses, triggering actions when rate surpasses this particular set limits. Additionally, scope down statements can be incorporated into rate limiting rules to focus on specific requests that matches the particular statement. Our infrastructure relies on this combination of Edge, Shield, and WAF with all the request context to bolster security as well as protection against DDoS attacks, ensuring uninterrupted service availability. As I said earlier, with the privileged position that Edge sits in, it generates insights for each request which are generated in the form of events. Every event has subtle data around the request. It also identifies whether the request is malicious or not. And also there are detailed data and insights such as IP level, origin of the request, and much more. These events are fed into machine learning models in real time, which are built in-house. This model generates multiple insights which fall under two primary categories. The first category is to identify malicious pattern or abuse traffic, which is near real time. Any similar pattern observed via the machine learning model will result into addition of a web application firewall rule to block such traffic. The second category is to derive rate limits based on the historical patterns. Based on the usage as well as the periodical analysis, rate limits are derived, which can be based on request data such as IP, user agent, customer, etc. Or it can be a combination of all the parameters which I've mentioned just now. Addition of the rate limiting or blocking rules at the web application firewall, as well as Edge to throttle or block the context identified in the previous steps, Razorpay routes all these requests through its API gateway. And there are some vital recommendations which are being adhered during this particular process. First is pattern-based malicious request detection. It utilizes feedback data to assess whether incoming requests exhibits malicious patterns. If the confidence percentage indicates a high likelihood of a malicious intent, then we promptly block the request at the WAF layer itself. Second, rate limiting with machine learning insights. Implementing rate limiting based on the insights that are generated at edge and being actively fed to the machine learning model, which also constitutes of pre-existing data within the request objects. This proactive approach helps in preventing excessive request rates. Third, dynamic rate limiting with all these insights. Apply rate limiting rules as well as limits dynamically based on extracted data using the request object. We also utilize the machine learning pipeline feedback to adapt rate limits as we need, and thus furthermore enhancing the security. One of the practices that we also use along with this is captcha verification. Let's say for any request that has a malicious intent or where edge indicates a low confidence, is directly served via captcha verification. It helps in verifying the user's authenticity and protection against automated attacks. Fourth, with all of these details, we also maintain that we publish these insights regularly to a data store. As a best practice, promptly publish insights generated for each request to Apache Kafka outside the request flow. This helps in mitigating the latency impact and also reduces the potential impact of any issues, ensuring smooth and efficient request handling. All of the above pointers helps us in continuous feedback loop between Edge and the data store to publish insights in further identifying the pattern of the upcoming requests. Let's talk about some of the numbers which Edge receives on a daily basis. For a request, we do have a combination of single as well as multiple rate limiting rules. On an average day, Edge supports a peak of nearly 55,000 rate limit evaluations per second, which helps in mitigating DDoS attacks in any manner. When I say about rate limiting evaluation, it is the number of rules that are being evaluated per second for any request. As we keep on onboarding new routes on Edge, this number keeps on increasing. Edge has been thoroughly tested to support as high as 500,000 requests per second. All these high operations are carried out within a peak of 9 millisecond P99 latency. As you can see, all of the features I would like to give a brief about what I have mentioned earlier. Edge uses internal shared memory cache on top of Redis to throttle faster. We use machine learning models to derive insights to automate rate limits using the historical patterns that are being identified. We group all of the multiple rate limits within a single Redis call in order to ensure latency is not impacted. This optimization further ensures that the Redis calls are correct using the adaptive strategy that I mentioned earlier. Edge now have an automated response to any sort of DDoS, which helps in prevention as well as mitigation using a combination of rate limiter plugin as well as the web application firewall or the AWS WAF. Let's move to other key feature that we have built at Edge to ensure performance remains consistent. Load shedding. To manage excess traffic and also ensuring the reliability of our system, we developed a plugin on Edge called Load Shedder, which can drop non-essential requests during high traffic times. As you can see here in this particular diagram, we have segregated the traffic into three categories. On top of it, this plugin is pretty lenient in terms of deciding the correct metrics. So how this plugin works is the user has to provide all of the metrics which are being needed to be calculated during the request flow. A simple Prometheus endpoint is being used to call upon the particular metrics that are being exposed, and on the basis of the threshold that has been set as a plugin configuration, Edge decides whether to go ahead with load shedding capability or not. The plugin is pretty lenient in terms of deciding the correct metrics. We allow our stakeholders to choose the right metrics suitable for their use case, and the custom metrics injection and threshold detection is what makes this plugin to detect granular spikes as well as cater all priority traffic at all times, which means no matter what, a user will be able to make payments throughout the day. Some of the key features that we do have is segregation, priority on the basis of route as well as services. We allow our stakeholders to inject custom metrics, and our in-house algorithm ensures critical services are up and running 24/7. Load Shader plugin helps in mitigation of incidents, and downtimes are really easily managed. The mean time to recover is pretty low during such incidents with the capability that we do provide via the load shedding plugin. We protect our upstream services, and we do ensure that critical traffic is handled during high load using this plugin. As always, priority is given to high customer experience during failovers and incidents, ensuring quality of services. So I would like to summarize the two of the plugins as well as the functionalities that I have described earlier. The power of edge infrastructure in the ever-evolving landscape of our infrastructure has emerged as a cornerstone of modern operational paradigms. Its unique position grants it a privileged perspective, enabling the acquisition of comprehensive insights for every incoming request. These insights, in turn, play a pivotal role in identifying a vast array of patterns, ultimately bolstering the efficacy of the rate limiter plugin. Moreover, edge infrastructure showcases remarkable scalability, supporting up to a million rate limiting operations across all routes and services. Alongside this, the load shader plugin ensures not only adherence to quality of service but also serves as a robust shield against incidents and outages that could jeopardize critical services. The seamless integration of these components is what sets edge infrastructure apart, guaranteeing both security as well as streamlined traffic management. At the heart of edge infrastructure's capability is its ability to gather and analyze comprehensive insights for each request. These insights serve as a foundation for proactive threat mitigation, with the rate limiter plugin being a key beneficiary. These insights serve as a foundation for proactive threat mitigation. It also relies on proactive thwart as well as mitigation of various attack vectors, including the notorious DDoS attacks. By leveraging the insights gleaned from incoming requests, the system can identify and counteract threats before they can inflict any sort of damage. This proactive approach marks a paradigm shift, transitioning from a reactive stance to a proactive defense strategy. Edge infrastructure scalability can seamlessly accommodate up to a million rate limiting operations spanning across all the routes and services. This scalability is a critical asset in the dynamic realm of our service, where traffic pattern can shift unpredictably as well as rapidly. The ability to handle such an immense volume of rate limiting operations is indispensable for preserving service availability and performance. Edge infrastructure scalability ensures that service remains responsive even during peak traffic periods, thus enhancing overall user satisfaction. While security often takes the spotlight, the load shader plugin silently operates in the background, guaranteeing not only the adherence to the quality of service standards, but also serve as a robust defense against unforeseen incidents and outages that could impact critical services. Quality of service is a foundational aspect of Razorpay, accommodating factors such as latency, reliability, as well as availability. The load shader plugin plays a very pivotal role in maintaining this quality of standards during unexpected incidents or outages that could potentially disrupt the critical services. The load shader plugin dynamically adjusts traffic allocations, ensuring the essential service receive the necessary resources to continue functioning seamlessly. This resilience is indispensable in today's digital landscape where even a momentary interruption in service can have far reaching consequences. Edge has the ability to synergize the rate limiter as well as the load shader plugin to ensure the holistic security and efficiency of the system. These two plugins, rather than operating in isolation, seamlessly collaborate to establish a robust and defense mechanism. The rate limiter plugin, fortified by the insights collected by edge infrastructure, diligently monitors incoming traffic and also enforces rate limits as needed. The load shader plugin complements this security-centric approach by prioritizing and allocating resources judiciously. When traffic surpasses predefined threshold or when external factors lead to resource scarcity, the load shader plugin intervenes to shield critical services from disruption. This prioritization is paramount for upholding quality of service standards and ensuring a consistent user experience even in the face of challenging circumstances. In conclusion, edge infrastructure represents a combination of robust capabilities. Its capacity to collect comprehensive insights for every request empowers it to proactively identify and mitigate a wide spectrum of threats, including formidable DDoS attacks. Furthermore, its scalability guarantees the continued responsiveness of services even amidst fluctuating online traffic. The load shader plugin further enhances this infrastructure by safeguarding quality of service standards and acting as an unwavering defense against incidents as well as outages. Together, these elements converge into a streamlined and resilient infrastructure superbly equipped to confront the challenges which are inherent. With this, I would like to conclude my presentation. Please reach out to us if you have any questions and suggestions around the topic. Thank you for joining me today, and I hope you found this talk informative as well as helpful.